So hey guys, let's talk about another lead code problem today, and that's the minimum operation to make binary array elements equal to 1. So we are given with an array that contains 0 or 1, and we have to apply some operations in such a way that we have to make that array all equals to 1. There shouldn't be any 0, all the elements should become 1. So these are the rules to apply the operation. We need to choose any three consecutive elements from the array and we have to flip. Flipping means we're gonna flip 1 to 0 and 0 to 1. And if it's not possible, if we are having any 0 left after converting all of them after entire operation, then we're gonna return as -1, else we will return the array. So this is our entire problem. Now let's just see one example. So this is the example given here. This is our array that contains 6 elements. So how are we gonna apply the operation? First we will choose first 3 elements like 0, 1, 1. So here 0 got converted to 1 and 1 got converted to 0 and again 1 got converted to 0. Again we will apply from index 1, that's the 0, 0, 1 on these 3 elements and see all these elements got converted. Then again we will apply from these 3 elements. So as we know that our first element is 1 and remaining 2 elements are 0. If we apply the operation, this element will become 0 and we don't want any element that's on the left side to become 0. So there won't be any operation. Then we will choose these 3 elements and we will convert it into 1, 1 and 1. So this is the flipping and we got our entire array that contains only 1. We have one more example that doesn't follow it. So this is the array. If we try to convert it, first we will take first 3 elements. So here we will get 1, 0, 0. In the next example, we will have 0, 0, 1. Even if we try to convert it, we will get 1, 1, 0. There would be 1, 0 left at the end. So there is no possible way to convert it into all 1. So that's why the output is negative of 1. So this was the example and I'll explain you the approach and how we can proceed for this particular example. So let's just see that part. So let's just see some observations to get or to make our algorithm to solve this problem. So first thing, we can only flip group of 3 consecutive elements at a time. If there are 2 elements, we can't flip it. If we have a group of 3 elements and that contains 0 and 1 both, so flipping it will never eliminate all the 0. For example, you can see we have this 3 elements and it contains 0 and 1, combination of both. No matter how much we try to flip it, we will always get as 1, 0 and 1, 1. So this is the first observation. The second thing is, if a 0 remains in the last 2 position, we cannot flip it because we need at least 3 elements that should be in the consecutive way. So this is the second observation. And the fourth most important thing is, we can flip the digits by taking XOR. We're not going to use the if else block or any other thing. We will use XOR operations. So as we all know that XOR with 1 always flips the element. We can just take an example. We have 0, 1, 1. And if we do XOR with 1, then we will getting as result 0 XOR with 1 would be 1. 1 XOR with 1 would be 0. 1 XOR 1, 0. So when we want to flip, we can use the XOR with 1. So this is the most important part, what we're going to use in our problem solving algorithm or whatever you say, the procedure. Then the most important thing is we'll be using greedy algorithm. So greedy algorithm is used to convert 0 at the earliest position into 1. So what does it mean? We will go from left to right in our problem. We will start converting this array to 1 from left to right. So we will try our best to make all the elements at left as 1 and proceed towards right. We won't need any element to be 0 in the left hand side. So this is what it's saying. Greedy algorithm is used to convert 0 at the earliest position into 1. And it would be with minimal operations. And what we're going to do in this procedure is we will check if nums of I is equals to 0. So then we will flip it and also the next two elements. And if it's not is equals to 0, in that case, we won't do any flip. So this is our entire idea how we're going to proceed. Now let's just take this example. Let me remove it. Okay, so this is our first example. Using greedy approach, how we're going to proceed? First, we will take first three consecutive element and flip it because first we have 0. It will become 1, 0 and 0. And all these elements will come at it is. Then again, from index of 1, we will take three consecutive elements again and flip it. So we will get 1, 1 and 0. We get flip because these elements were 0. If it was 1, we wouldn't do any flip and take these elements as it is. Then from index 2, it is 1, we won't do any flip. Then move here and flip it. So all would become 1. So I hope you got this point how it's working. Now this is our another example. So here we will take first three elements, all are 1, no need to flip. Again these elements, we won't flip because it's 1. Again these three elements and we won't flip because it's already 1. And if it these last two elements contain 0. So it means that we can't get an array which contains all 1. So it is impossible. We're gonna return -1. So this is our lead code phase and now we will solve the problem. So first what we're gonna do, we will take an element n which will store the how many elements are there in our array, means the length of our array. So let's just take int n is equals to nums.length. It wasn't required, but it improves the readability of our program. Then we also have to count the number of operations required. So we will take a variable operations and initialize it to 0. Then we will use a for loop to iterate through this entire array. For int I is equals to 0 and I will go till n minus 3. And I would be keep on increasing. Now we will check if nums of I is equals to 0 or not. And if it is equals to 0, in that case, we will apply the XOR operation. So we will apply XOR on nums of I, XOR with 1, then nums of I plus 1 as well as nums of I plus 2. Let me just write it. Then again on the nums of I plus 2. XOR with 1. And we will increase the operation also. So this is our operation part. After this, we will come out of this loop and we will start another loop to check if there is any 0 left in our array or not. So for that, we will take another loop. And this loop would be from n minus 3 because we want to check on the last two digits what are left there if they are 0 or not. And if those elements are 0, in that case we will return minus of 1. In other case, we will return the number of operations. So we'll just come out of this loop and we will return the operations. Sorry. Now let's just run this. Okay, so both the test cases got selected. So this was the entire problem for today. And just keep practicing, keep on learning. That's all. Thank you.